Why did you bring your pet fish with you?
We're replacing our broken aquarium at home. I'm going to put my pet fish at K-Hub's aquarium.
You mean there's an aquarium at K-Hub?
Yes.
Cool! Can't wait to see it.
Bye, fish.
Sir Mike, thank you for allowing my pet to share your fish's aquarium.
No problem, Christine. I'm sure they don't mind sharing their homes. Can you feed them later? I need to step out for a bit.
Sure, Yuri and I will feed them.
Bye.
With all those fish breathing inside, why don't they run out of oxygen?
Same reason as why, despite billions of people and animals are all breathing here in our planet, we don't run out of oxygen.
And that reason is?
Even with billions of people breathing simultaneously, the total amount of carbon in the environment remains constant. There is no destruction or creation of carbon in the oxygen-carbon dioxide cycle. It only involves the movement of these elements around a complete cycle in compound form.
So if there's no man or animal left here on Earth, will the total amount of carbon in the environment remain the same?
No. Plants, man, and animals are all dependent on each other when it comes to oxygen and carbon dioxide exchange. Man and animals need oxygen in order to live, and plants need the carbon dioxide to produce their own food.
How does the exchange happen?
Dr. Bio, a world-class teacher and holder of a PhD in biology, will explain the pathway of energy in our biosphere. She will be assisted by Ms. Erica Eunice Salvador, a teacher in Philippine Science High School Western Visayas Campus. Hi, ma'am!
Hi, K-Hubbers! We're here in the 7 basin waterfalls of Hawili in Tangalan, Aklan.
This is such a great place. The warm sun, the fresh air, and a picture-perfect view.
Away from the hustle and bustle of the city. Away from pollution and noise. Wait, noise?
Game over! I miss my TV and PSP.
How can you stand not seeing, feeling, and being one with nature, Enzo? This is such a rare experience for us.
I don't need nature. All I need is my comfortable bed in front of the TV and nothing else.
That's where you're mistaken, Enzo. Why don't you stay here with teacher Erica and see for yourself? Meanwhile, let me take care of that.
What do you need nature for, Enzo?
Food and shelter?
There is more to us being dependent to nature than food and shelter. Can you think of examples?
We inhale oxygen given off by plants.
Microorganisms in the soil decompose our waste.
Correct. Although we constantly receive energy from the sun, nutrients such as carbon, oxygen, and nitrogen have limited supplies, so they must be recycled over and over through ecosystems. The movement of carbon through the environment is called carbon cycle. For other nutrients, There are also the oxygen cycle, water cycle, and nitrogen cycle. The oxygen-carbon dioxide cycle is one that focuses on the exchange of carbon dioxide and oxygen between plants and animals, but it overlaps greatly with the other cycles. Guys, let's make a story out of these nutrient cycles. Game?
Game!
Okay, I'll start. The driving force behind the oxygen-carbon dioxide cycle are the processes of respiration and photosynthesis. The general chemical equation for photosynthesis is as follows.
6 molecules of carbon dioxide plus 12 molecules of water in the presence of light forms 1 molecule of glucose plus 6 molecules of oxygen plus 6 molecules of water.
Your turn, Alfonso.
During photosynthesis, carbon as carbon dioxide moves from the atmosphere to plants.
Producers such as plants and algae take up CO2 from the air or water around them. The producers use carbon dioxide and water to manufacture glucose, an energy-rich organic compound. During this reaction, oxygen is released.
Ma'am. Then carbon as glucose and oxygen gas moves from plants to consumers.
Organisms use glucose to fuel the process of cellular respiration. In this process, glucose breaks down as it undergoes a chemical reaction with oxygen. The reaction produces energy, water, and carbon dioxide. That's why we breathe in oxygen and exhale carbon dioxide.
Respiration follows the reverse of the chemical equation of photosynthesis.
Following the reaction, 1 molecule of glucose plus 6 molecules of water plus 6 molecules of oxygen is transformed into 6 molecules of carbon dioxide plus 12 molecules of water plus energy in the form of 36 ATP. The exhaled carbon dioxide is released back into the atmosphere.
Correct. Photosynthesis and respiration allows the circulation of carbon dioxide and oxygen among plants, animals, and the atmosphere. Another major exchange happens when atmospheric carbon dioxide dissolves in the ocean for the use of aquatic organisms. Also, this carbon dioxide may readily diffuse back to the atmosphere.
But ma'am, in the carbon cycle, the carbon from food may also be used by organisms to produce tissues and body parts like exoskeletons or shells.
When these organisms die, carbon moves from the animals to the ground. They may produce carbon dioxide back to the atmosphere when they decay, or they may become fossil fuels if they remain buried for millions and millions of years, as coal, petroleum, or natural gas.
You're right, Alfonso. Also, the oceans contain much of the world's carbon, existing as carbonate and bicarbonate ions.
Aquatic animal shells and corals, which are composed of calcium carbonate, may become sediments and form limestone. Limestone accumulates in the ocean floor for a very long time. The atmosphere, ocean, fossil fuel, and limestone are among the reservoirs of carbon. These are the means by which a nutrient remains undisturbed for a very long time.
Interesting. Now going back to atmospheric carbon dioxide, let's take note that their sources are the respiration and decay of plants, terrestrial animals, algae, and marine animals. Also, landforms such as volcanoes release considerable amounts of carbon dioxide in the atmosphere.
On the other hand, in the oxygen cycle, the largest reservoir of oxygen is the minerals of the soil.
It moves to and from the Earth's crust by the processes of burial and weathering. In the atmosphere, it may form ozone, which blocks out the sun's UV rays. The major source for atmospheric oxygen is photosynthesis.
Oxygen may also be produced during photolysis. That's when water vapor and nitrogen oxide in the atmosphere is broken down by ultraviolet light. Also, oxygen is already present in the previous processes that we have mentioned, like the production of animal shells and limestone or calcium carbonate. Also, oxygen is used up during animal decay and chemical weathering, like rusting.
Also, let us not forget that oxygen enters the water cycle.
Water from the oceans and other sources undergo evaporation, condensation, precipitation, and back again to form a cycle.
But that's not all. Water also cycles through living things.
Plants take up water through their root systems and evaporate it off during transpiration. Animals acquire water by drinking and lose water by perspiring, urinating, or exhaling water vapor.
Water may also seep into the ground. They may stay there for long periods of time or end up in wells, springs, or even back to the sea.
Wow, these cycles are really interrelated. This plot is more tangled than a drama series.
But there are some special characters in our story. Who could they be?
Characters? Well, humans, of course. Because of our burning of fossil fuels, carbon dioxide is released into the atmosphere when it's supposed to be deposited underground. CO2 is also released in the burning of trash and the burning of trees in Kaingin.
Chemicals, sewage, and trash pollute our rivers. Deforestation stops the transpiration process, keeping the ground abundant with water and susceptible to flooding and erosion.
Hey, why are there so many factors contributing to the increase of carbon dioxide while we only have photosynthesis for the increase in oxygen? That's so unfair, and carbon dioxide is just another greenhouse gas.
You have a point, Enzo. What's worse is that when carbon dioxide accumulates together with other greenhouse gases and dust, it forms a dark, dense cloud called smog, short for smoke and fog. Smog brings acid rain when carbon dioxide reacts with water to form carbonic acid.
Scary. Humans seem to be the villains in this story.
But, you know guys, humans can be heroes too. I know lots of people who organize cleanup drives, tree planting activities, and other projects for the care of our natural environment.
So, do you want to be villains or
hero.
Well, I want to be a hero.
Did you enjoy yourselves, students?
Yes,
ma'am.
Very good. Now I'm returning this to you, Enzo.
Thank you, ma'am, but I'll be keeping this for now and do my part in appreciating and helping nature in my own little and heroic way.
Now that you've learned that all organisms, as well as the water, the soil, and even the atmosphere provide nutrients for our survival, let us keep in mind that we cannot be forever indifferent to our environment. We only have one Earth with its nutrients being recycled over and over. The Earth is ours to keep, but it is also ours to maintain if we want it to stay as our home, sweet home.
Ma'am, there's a new high score.
Bye, K-Havers!
Bye!
Having heard all that, can you tell me the importance of the chemical cycles in our ecosystem?
Sure, chemical cycles...
Wait! I'll just feed my pet fish and I'll get back to you.
Wait!
Now, where were we? Oh yeah! What's the importance of chemical cycles in our ecosystem?
Balance is essential to the Earth. Chemical cycles keep the amount of elements on the Earth in a perfect balance.
And how do we keep this balance?
We must nurture plants as part of nature, and is a major source of life's energy.
We must also be aware that animals and we humans are dependent on plants for food. So we should participate and build new world for plants to live, survive, and to supply us with more energy.
Just like how the plants are putting oxygen back in the air as they are producing their food in our aquarium.
Exactly.